So now we are going to talk about the application of I effect of inductive effect. What are the applications of inductive effect? So we know we have studied the inductive effect. We have seen R2 effect plus I effect and minus I effect. Now what is their use? So first use is compare the stability of reaction intermediates. Now what are the reaction intermediate? We're gonna see here. And second, compare the acidic and basic strength. We have to compare the acidic and basic strength. Now first of all, let's talk about what are our reaction intermediates. What are our reaction intermediates? First is carbocation. Second is carbanion. Third is carbon free radical. Fourth is carbene. Fifth is nitrene. Sixth is benzene. So these are the intermediates which form in between the reaction, and that's why they are called the reaction intermediate. They are formed in between the reaction, right? So let's discuss each and every reaction intermediate in brief. First, talk about carbocation. What is a carbocation? Carbon having a cation, like a carbon having three atoms attached to it, X, Y, and Z, and it has empty p orbital because we have removed one hydrogen from it. So first, it is sp2 hybridized. Its hybridization is sp2. Second, it's trigonal planar. Third, it has a positive charge. Fourth, it has p orbital is perpendicular to the plane. P orbital is perpendicular to the plane, and it has 6 electron in outermost shell, and it is an electron deficient species. It has incomplete octet. It is a Lewis acid due to having incomplete octet, and it also worked as an electrophile, electron loving. Electrophile means loving. It is diamagnetic because it has 6 electrons in outermost shell and all are the pair. That's why it is known as diamagnetic. Now let's talk about its stability. Stability of carbocation is directly proportional to plus I effect, and it is inversely proportional to minus I effect. More the positive I effect, more is the stability. Why? Because whenever it has a carbocation and you are having a plus I group attached over here, so they will actually push the electron towards it. When they will push the electron, they will de-intensify the positive charge. Less the intensity of positive, more will be the stable. Let's compare this, see the energy level when you have a positive charge and when you have a negative charge. They both have higher energy and least stability, and a neutral molecule has a high energy. So when you are providing electron to positive charge or pulling electron from the negative charge, you are sending it towards the neutrality. You are sending it towards the neutrality. So if you are pushing electron to the positive charge, the positive charge is getting negative charge, and overall it is less de-intensifying the positive charge. So it is directly proportional to plus I and inversely proportional to minus I effect, because minus I effect will pull the electron and it will be intensifying the positive charge. Let's say we have an minus I groups over here, CH2Cl. So it will pull the electron over here. So it will be intensifying the positive charge, means they are making it unstable, they are making it, right? So first is CH3, you have to compare the stability CH3 CH2. First, second is again you have to compare the stability. CH2 positive and CH2F, CH2 positive and CH2Cl, CH2 positive are CH and Br. Third, again I'll give you time, you would be solving by your own. Positive fluorine, positive charge methyl group, positive charge CD3, positive charge Cl. Fourth we have fluorine over here. Fifth, sixth, so these are some illustration. I'll suggest you to pause the video and try to answer by your own. So these are the some questions. I'm giving you time. First pause this, solve this. Now pause this and solve this. Now let's talk about the answer. Now it is having only one methyl group. It has 2 plus I group and it has 3 plus I group. So stability, it will be more stable. Fluorine, chlorine, bromine. It has more minus I. It has lesser minus I, lesser minus I. So more minus I de-intensifying. Most minus plus I have CD3. Second plus I is CH3. Third plus I is Cl. And fourth is fluorine, because it is more minus I. Here we have 2 methyl group, right? So 2 methyl group are being attached, and here 2 fluorine group. It has minus I group attached, it has plus I group attached. So it eventually pushing the electron, so it is more stable. Now, if we talk about these two questions, if this have oxygen is pulling electron, So it is showing minus I, and it has no, it has plus I. This carbon has plus I. So what we do, we have to we see what we see what we see that we say that whenever there is a difference, then we talk about the difference, right? So we compare from the difference. Here we have CH2 and CH3 and NF3. It is minus I group and it is plus I. So it is pushing the electron. Now if we have oxygen and we have carbon, we have oxygen and we have carbon, again it is showing minus I and it is showing plus I. So it is pushing the electron. Here it is 3 degree carbon, it is 2 degree carbon and 1 degree carbon. One side pushing electron, two side and three side. So this, that will be the order. Cyanide and it is sp hybridized more electronegative, sp2 hybridized less electronegative. So it will be the answer. OH If we talk about the electronegativity, fluorine, oxygen, nitrogen. The oxygen is more electronegative, nitrogen is less electronegative. So it has more plus I, lesser minus I. In these two, we know of phenyl, this is the most electronegative, and this is the least electronegative. So 1, that will be 2, and that will be 3. So that's how we talk about. Now there are some good questions, like whenever you have this is important, very important. Suppose you have positive charge, and here you have 2 chlorine, and here you have positive charge, and here you have 1 fluorine. So which having more plus I and which is more stable? Obviously which has less plus I, and that is more stable. Actually so what we consider, it has more intense, more negative I, but number is 1. It is less negative I, but number are 2. Less negative I, but number are 2. So which will be having more minus I, more plus I. So what we do, we give a statement that number dominates over power. So more number, both should be same behavior of group. Both should be plus I or minus I. So here it is, its power is more. A number is less, but number is more, but power is less. So its effect, overall effect will be more. So it has having minus greater plus I, so it will be stable. So a number, here number dominates over power, it having more minus I effect. Now positive, let's say here we have chlorine, and here we have fluorine. Now chlorine has like less power, fluorine having more minus I. So whether the distance dominate over power, so here also distance dominates over the power. Distance dominate over the power. So distance is more. Here distance is more, but power is also more. But here distance is less, so it having more minus I. So that will be more stable. It has more minus I effect over positive charge. So these two are important terms. The number dominates over power and distance dominates over power. So distance dominates over power. Now when we talk about free radical, second free radical. When we talk about free radical, what is the free radical? We have C, X, Y and Z, and we have one odd electron species. So first it is sp2 hybridized, second it is planar. Now and this is odd electron species, and in the most probably you might have seen how do we calculate the hybridization of odd electron species. Here second is planar, third is it has no charge, fourth is 7 electron in outermost shell, fifth it has incomplete octet, sixth it has electron deficient, 7 it is Lewis acid, it is not a Lewis acid because it do not have empty p orbital to accept the lone pair. It has half filled, fully filled. So it is a electrophile. It is not a Lewis acid, but it is an electrophile. It is paramagnetic. These are paramagnetic compounds. These compounds are paramagnetic. And the last point is stability. Stability of these is directly proportional to plus I and inversely proportional to negative I group. So it we treat it same during calculating during calculating the stability through inductive effect. Inductive effect. Consider it is same as carbocation. We consider it same as carbocation while considering the stability with the plus I or minus I group because it is an electron deficient same as plus I. Carbocation, it is electron deficient. So we won't be any differentiating while answering the positive charge carbocation or carbon free radical, comparing the stability with the help of plus I. So let's look through some examples over here, so you will be better understand. So let's do some examples that free radical over here. Here we have Nr3 plus, and free radical over here we have CH3. Second, CH2 free radical, CH2 pH, CH2 free radical, CH2 CCl3. Third, CH2 free radical and CF3. Here also we have CH2 free radical and we have CH3. Fourth, here we have NO2, CH3, and here we have NO group. Fifth, we have question over here, we have free radical over here, and we have fluorine over here, and we have one methyl more over here. Sixth question, we have free radical over here, and we have non double bond over here. Seventh, let's form a seventh question, which says we have NO2 over here and we have cyanide over here. So what happens? So more the stability stability directly proportional to plus I group, inversely proportional to minus I. So it is pulling electron and it is pushing electron. So it is destabilizing and it is stabilizing. So this side will be the stability order. In second case, the stability will be this is more plus I, more minus I. It is more minus I. CCl3 is more minus I as compared to phenyl is more. It is more minus I and it is less minus I. So phenyl will give it more stability. We can see with the help of minus I table, and we can calculate the values. And CS3 it is plus I and it is minus I group. NO2, let's talk about the plus I. It has first number, it has second number, and it has third number. We can say more minus I or less, more plus I or less minus I. Okay, we're writing that order. Fluorine here destabilizing hydrogen as compared to fluorine, which is not actually destabilizing. So it will be the stable. So let's talk about the stability. And here is the methyl group. So it is first, it is second, and third. Because in case of methyl we have hydrogen, right? So whenever we are adding methyl, so it is actually eventually increasing the positive charge density. Here we have minus I. So minus I is actually destabilizing. So it will be the stability. NO2 and CN, NO2 has more minus I, so CN will be having more stable than NO. So now let's talk about carbanion. Let's talk about the stability of carbanion. Third reaction intermediate, that is carbanion. What are the carbanion? There is a negative charge on carbon. Let us see have a negative charge. X, Y, Z. So first it is sp3 hybridized. Second, it is trigonal planar. Third, it has 3 sigma bonds. Fourth, it is 1 lone pair. Fifth, it is negative charge. Sixth, it is 8 electron in outer motion. Now it is first, which has 8 electron in outermost shell. It is electron rich. It is dimagnetic. And again, its stability. Now negative charge will pull the electron, so it will affect the negative charge will and inversely proportional to plus I effect, minus I effect and plus I effect. Now let's solve some problem related to negative the stability of carbanion. Now let's say we have first question negative. Let's solve differently. Let's write questions here. We have first problem. Here we have negative charge, and here we have negative charge, and here we have negative charge. Second problem. Here we have negative charge. Here we have negative charge. Third problem. CH double bond C CH2 and CH2 negative. CH2 double bond CH CH2 CH2 negative. Fourth we have negative over here, and fourth we have fluorine fluorine negative over here. Fifth we have CH2 minus F, CH2 minus Cl. Sixth we have negative charge in a double bond. Seventh we have Cl negative. Negative. Eighth we have negative NO2, negative NF3. Ninth we have fluorine. Now first let's solve this. Let's write some more problems to get the get come in better practice. 10th we have this group. Here we have a chlorine and fluorine. Here we have chlorine and chlorine. 11th we have fluorine. 12th we have fluorine, fluorine. Here we have fluorine, 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 fluorine. 13 we have CH3, CD3, CD3. Now I'll suggest you to pause this video now and solve. Pause this video and solve. Now let's solve the problems. First you try by your own. That will be a best way to practice this question. Think by your own, then check the answers. So we know it is 1 degree carbanion, it is 2 degree, and it is 3 degree. So this will be more because less should be my plus I to stabilizing the negative charge, and here also this. And we talk about it as more minus I, it has less minus I. So it is more minus I, so it will be more stabilizing. Now it will be more stabilizing, more minus I. It has more minus I, so it is more stabilizing. It is more minus I, it is more stabilizing. And here the negative charge, the chlorine is here is closer, and here it is farther. So closer will put more minus I. NO2, NF3, NF3 plus has more minus I. And if fluorine attached over here instead of hydrogen, it has more minus I. Now 2 chlorine, 1 fluorine, chlorine, it is first, it is second, and it is third. Now it has first and it has second, because here we have it is fluorine, which has a minus I effect. Here it is more minus I, and here it is more plus I, so less minus I. So less minus I means here it is more minus I. So CH3 is more stable than CD3 minus, and CH3 with CT3 with a negative charge over here.